This is lesson 2.4, division with fractions in pre-algebra. And we just got done with multiplication with fractions, so division with fractions should be pretty easy. So first of all, what we need to do is talk about what are called reciprocals. Okay. A reciprocal is a number that actually two numbers that when we multiply them together we get 1. That's what a reciprocal is. So if we take 3 over 4 times 4 over 3, we get 12 over 12, which equals 1. So notice what happened here is this fraction and this fraction are the exact same number, they're just in different positions. One is flipped, this one is flipped upside down. And that's what division is. If we were to have a division problem like 3/4 divided by 1/3, what we would do is we would multiply by the reciprocal of 1/3. We take the bottom number and we put a times sign and we flip it over. So instead of 1 over 3, it becomes 3 over 1. And that equals 9/4. Because what this is actually saying is how many 1/3 are there in 3/4. Now that's kind of a complicated question. How many 1/3 are there in 3/4? That would be really difficult to draw a picture and try to figure out, but when you can multiply by the reciprocal, it all works just fine. So that's all a reciprocal is. Alright, so when we divide by fractions, we never actually divide, we always multiply by its the bottom numbers or the second number's reciprocal. So let's show a couple of those. 1/2 divided by 1/4. So there's my second number. So I'm going to change to a times sign and flip it over. And then I get 4 over 2, or 4 over 2 is reduced to 2. If I have 3/8, and this is example 2, and it's divided by 9 over 4, it's 3/8 times 4 over 9. Now when you have something like this, you want to make sure that we reduce or cancel before we go any further. So 3 over, and what I'm going to do here is 8 is actually 2 times 2 times 2, but if I put these two together and have 4, I can cancel with this 4. So I'm just going to leave it as 2 times 4. I'm not going to reduce it all the way to the primes. And then I'll leave this 4, and then I'll reduce this all the way. And I can cancel that, and that, and that, and that, and end up with 1 over 6. Now let's say that I do reduce it to the primes. If I put my 8 as 2 times 2 times 2 times, and my 4 I'm going to make 2 times 2, and my 9 I'm going to make 3 times 3. So I just took this here and wrote it as product of primes. I can cross out those two with those two, that one with that one, and I still get 1 over 2 times 3, 6. So it doesn't matter whether you use this method where I just reduced it to what I could cancel or reduced it to the product of primes. You're going to get the same answer. It's just this top one here is a little bit quicker, so that's why I do that. So you can do whichever one is the best for you. Alright, so let's take one from example 6. 16 over 35 divided by 8. So when I divide here, I'm going to multiply and change my times to multiply, and this is really 8 over 1, so I'm going to multiply it by 1 over 8. Okay, so I'm going to change this to 2 times 8 so that it matches that. 35, I don't really need to find the product of primes because there's nothing on top that's going to cancel with it, but I'll put it on there anyway. And we'll do that. That cancels with that. And we end up with 2 over 35. Okay. And when you're given another one in example 6, like 27, oops, they've got it written different, divided by 3 halves, we're going to write it as 27 over 1 times, and we're going to flip them. And we're going to reduce that, because that's 3 times 9 over 1 times 2 thirds. Cancel that, and we end up with 18 over 1, or just 18 there. So let's jump up to example number 7. It says the quotient of 8 thirds and 1/6 is increased by 5. So the answer to the division, so if we have a division problem, 8 thirds divided by 1/6. So they're saying that if we were to do that and get an answer, and we would increase that answer by 5, and they want to know what that number is that we would get. So when they use the word quotient, that means they want you to divide. Before you do anything else, you always change it to a times sign first. Flip that over, and then we add 5. Okay, now we can go ahead and do the work here. 8 thirds times, I'm going to change the 6 to 2 times 3 over 1, so I can cancel those. And then I can go 16, and then I can add this 5 here and get 21 for my answer. Alright, let's look at example number 8. They get a little bit trickier and trickier, but really not too hard. As long as you do each step one piece at a time, it shouldn't be too much trouble. So 4 thirds squared plus 75 divided by 5 halves the quantity squared. Okay, so let's look at this in pieces first. First of all, we do the plus last. Okay, remember PEMDAS? We do our addition and subtraction at the very end. So we're going to do everything over here and everything over here, and once we do all of that, then we're going to add them together. But you never do the addition early. Do everything else first. So this is kind of a line that says don't cross the line. Do everything over here and then everything over here, then you can cross the line and combine things. So if you remember, using PEMDAS, we do what's in the parentheses first. And this is 16 because we square the 4 and then we square the 3 so that that goes away. Plus 75 divided by, and we're going to do the same thing over here. We're going to square the 5. Don't forget to square the top and the bottom. And we get that. And that goes away. Alright, now what we're going to do, because we have our division, we're going to flip those over. So we're going to make them a times and make this 9 over 16. I'm not going to do anything to it yet. And 75 divided by, and we're going to flip, oops. We're going to make that a times. Flip. We're going to flip that around. Okay, so next step is we're going to, well, it might be easier if I put this over 1 and this over 1 so that you can see that we're multiplying 2 fractions there and 2 fractions there. So let's make these into some factors. 32 is the same as 16 times 2. Now again, I can change that 16 to 2 times 2 times 2 times 2, but what's the point when I can leave it as 16 and be able to cancel with this 16? Okay, and then I'm going to do the same with my 75. I'm going to change it to 3 times 25. And again, it could change. This could be reduced to 5 times 5, but we're able to cancel it with our 25 down here. So we don't want to do that. So let's go ahead and cancel that. Cancel that. We already canceled the 16s. That leaves me with 18 over here, because I have 2 times 9, plus 3 times 4, is 12, and all I have to do is add those together, and I get 30. And that's it for lesson 2.4.